Okay, well, we dropped the camera when we turned it off there, but it seems to be working. Wow, that was scary. Okay, so what were we just talking about?
This circle and how many circles don't intersect it and how many circles intersect it.
Okay, good. I hope that doesn't happen again. Anyway, so what, sorry, the camera dropping kind of made me lose track of what we were talking about. So what did you think?
I thought there were infinitely many that don't intersect this and infinitely many that intersect this circle.
Okay, and what did you think?
I thought there was finitely many that don't intersect and there was infinitely many that don't intersect and finitely many that intersect.
Okay, so we have a slight disagreement on this then. So why do you think there's only finitely many circles that intersect it?
Well, because if there's circles that are inside, if there's circles that are outside, they're eventually going to get down to the size where it doesn't intersect anymore. So the circles will be inside this area here.
Okay, cool.
But like there'd be 1/100th, 1/1000th, and this circle is really small.
Yeah, and so what's happening to those really small circles?
They're getting smaller and smaller. So maybe there are finitely many outside, but there would be infinitely many inside. Yeah. That's for sure.
Okay, so do you think we've come to an agreement on that?
Yeah.
Okay.
So finitely many intersected, but infinitely many on the inside.
That don't intersect.
What about this circle here?
Well,
This one up here.
well, the only one that intersects that one is the big circle.
Okay.
And there's no other circles.
What if I slid it down here so that there were two circles intersecting? Can you imagine that, or do you need me to draw that?
No,
I can imagine.
Yeah.
Okay, now, why don't I draw it anyway? Slide it down here so that it intersects two circles.
And then
What happens if I make these two circles now half the size of each other? So I make smaller circles.
And then this is the number inside is going to stay infinite. And on this circle here, the properties are going to stay the same. But on this circle, I think it's the number of circles that intersect is going to shrink down to 1 again.
Ooh, okay. What do you think?
So you're just drawing one inside?
Yeah, or I'm kind of shrinking the circle down. That's probably a better way to say it. What do you think happens as I shrink the circles down?
If you shrink it, the more you shrink it, this circle is no longer tangent with this one.
Okay.
So you have to move it down again, and if you keep shrinking it and moving it down, you're eventually going to shrink it and move it down to this point.
Okay, interesting. And so in order to keep it intersecting more than one circle, I got to keep it moving closer and closer and closer to that point.
Mm-hmm.
What happens if I keep it fixed always on the same point?
Then the circles that are outside it, like the circles that intersect it, it stays at 1.
Okay. So we just found this is the kind of thing that topologists look at, and this is kind of what Evelyn Lamb's article was talking about. One interesting thing about this shape is there's a special point, and on that point, no matter how much you shrink the circle, when you draw a circle around that point, there's always infinitely many circles inside of it, no matter how small that circle is. But other points on the big circle, even on other smaller circles, other points, eventually you can shrink a circle small enough where it only touches one circle. So that's something that's neat about the points on the outside of this special point, and then something that's neat about the special point.
Cool.
Okay, now we're going to look at something else called I forget what it's called. I'll tell you what, let me read the article and then we'll do the next video, okay?
All right.
And hopefully not drop the camera.